Hello students, myself Hardik Patel from LJ Institute of Engineering and Technology. In today's session, we are going to start with a logarithm function. You have learned basics of logarithm function. Before going on to the logarithm function, in last session, we have seen what is the exponent. If you have something a raised to y, a raised to x is equal to y, then only you can define the logarithm function as x is a log of y, where you have the base of log is a. Okay, that means if the exponent function is defined, then the inverse of exponent function is going to be a logarithm function. Here again, log has a base same as the base you have written in a exponent. Okay, whatever the power now you have, that index is going to be a value of a log function of the value of exponent. Okay, so this is the basic logic. That means, see, if you are writing a raised to x is equal to y, that implies x is equal to log y base a. Please remember this thing. Done? Now we are starting with the basic laws of logarithm. Okay. So first law is log x plus log y with same base is going to be a log of xy. That means you have to multiply x and y in a log. Then if you have log x minus log y, then you have to take a division of log of x by y. Same manner, suppose you have log of x raised to n, then whatever the power n you have, it is going to be in a multiplication of a log. Same manner, if you have log of log of nth root of x having base a, then it is going to be a log of x raised to 1 upon a. And now by properties of power, log, whatever the power, it is going to be in multiplication of log. So you have 1 upon n into log x base a. The standard property log 1 always has a value 0. If you have base a has any value, then also it has a value 0. Now see, log infinity has a value infinity if the base a is greater than 1. But suppose if the base a is less than 1, then log infinity has a value minus infinity. Same manner, log 0 has a value minus infinity if a is greater than 1, but it has a value plus infinite if a is less than 1. That means suppose I am writing that log of infinity base 1 by 2. Now 1 by 2 is less than 1, correct? So in that case, this has a value minus infinite. Done? And the last property is a change of base. And in change of base, if you have a log x base y, then it can be written as log x upon log y, where both has the same base. Numerator and denominator both has the same base. You can write down any third base a, b, c, whatever you have to put it. Now, if you have a log x base e, then we are going to write it as ln. Natural log, we are now onwards, natural log we are going to write in a form of ln. And if you have base 10, then we are going to write it in a form of log. Okay. Please remember, now in engineering mathematics, if you have given a log, correct, then we are generally considering it as a base e. If you have given base 10, then only we have a base 10. See, ln is not the universal notation, but generally we are deferring it by ln and log to understand. Okay. So suppose first example we are going to take is log 0.01 divided by having base 10, correct. So I am starting with, if you are starting with a solution, then you have log 0.01, correct, having base 10. So I am going to write this as 0.01, that means 1 upon 10, 100, correct? 1 upon 100. So we can write this as 1 upon 10 square, and that will be a 10 raised to minus 2, correct? So this is going to be, by property of log, whatever the power is going to be in a multiplication of log. So you have a 2 log 10 base 10. Now 10 base 10 has a value 1. See, here we have to take one, write down one another property. Basically, if you are aware of, log a base a always has a value 1. Okay, please remember this thing. Okay, so the answer of this one is minus 2. So please remember, same manner, this is a simple example, simplify. Now simplify, that means you have given log 4 base a plus log 2 base a. Then we are aware of, if both bases are same and you have log a plus log b, then it is written in a form of log a into b. That means 4 into 2. That means you have log 8 base a. Done? Okay. Now we are going on to the solution. You have given that log 9 base x is 2 by 3. Now you have to find the value of x. Now the first we have written that a raised to x is equal to b, that implies x is equal to log b base a, correct? So this is both side true equation, both way true. That means you can write down the double implies this way and this way. So from this one you can go to this one, and from this one you can go to this one. Okay. So what we are going to do, if you have to solve this equation, then a raised to x is equal to b, then you have x is equal to log a base b. So here your base is x, correct? So instead of a you have x. So here you have to write down x raised to whatever the power of equal to you have. That means in equal to you have x is equal to 2 by 3. So x raised to 2 by 3 is equal to 9. Done? And that will give you x raised to 2 by 3 raised to 3 by 2, because you have to find the value of x. So I am going to take both sides power 3 by 2. So this is going to be a x, and 9 raised to 3 by 2. Now first I am going to take a square root by 1 by 2. 9 raised to 1 by 2 is 3. So you have a 3 square, and that will give x is equal to 27. This is the method. Done? So this is how we are going to find the value of x. Same manner, here we have, instead of a direct, we have a equation. So if you are starting with a solution, then here you have given that log x base 4 and log x minus 12 base 4 is equal to 3. So log a plus log b, or log x plus log y, is log of x into y. So here base is 4. So you have x into x minus 12 is equal to 3. Correct? So if you are going to simplify, if we are going to remove the log, then we have x into x minus 12 is equal to 4 cube. Done? So this is going to be a x square minus 12x is equal to 4 cube is 64. That means x square minus 12x minus 64 is equal to 0. Now we have a quadratic equation and we have to factorize it. So we have 16 into 4. So minus 16x plus 4x minus 64 is equal to 0. Pair them up. So you will have x into x minus 16 plus 4 into x minus 16 is equal to 0. So we have a two factors, x minus 16, x plus 4 is equal to 0. So we have a value x is equal to 16 or x is equal to minus 4. Now see, x is equal to minus 4 is not possible. Why? Because we have not defined the log of negatives. Minus 4, if you are going to substitute here, then log minus 4, and here you have log of minus 16. So minus 4 is not possible. So your answer is 16. Okay. So the final answer is x is equal to 16. Same manner, here we have another equation. So if you are going to start with a solution, then you have log of x plus 1 base 2 minus log of x minus 4 base 2 is equal to 3. So if you are using the property, then log x minus log y is log of x by y. So x plus 1 divided by x minus 4 into 3, and that will give you x plus 1 upon x minus 4 is equal to 2 cube. Correct? 2 raised to 3, that will be this. That means x plus 1 upon x minus 4 is equal to 8, and that will give you, if you are going to cross multiply, then x plus 1 is equal to 8x minus 32. So taking x this side and 32 this side, so 33 is equal to 7x, 8x minus x, and that will give you x is equal to 33 by 7. This 7 is going in denominator. So this one is our answer. Done? Now, this is a very simple example, and it is an example of a simplification, not the solve. Here you have log x square upon y square plus log y square upon z square minus log x square upon z square. Correct? So see, if you are using the property of log directly, then log a plus log b, that will be a log a ab. That means you have to multiply x and y. And minus, that means you have to apply the division. This divided by this. So this is one term, this is another term. So divided by z square upon, x square upon z square. So here y square cancel out. And you will have x square by z square divided by x square by z square. Or I am going to write this as x square by z square into z square upon x square. Division can be written in the form of multiplication by taking reciprocals. Z square, x square will be cancelled out, and you will get log 1. Now log 1 is always 0. If you have any base, then also the log 1 has a value 0. So this one is the answer. Done? Now, this is the very interesting example. See what you have given, log 3 into log 4 into log 5. Here we have log 3 base 2, log 4 base 3, log n plus 1 base n is equal to 10. Then find the value of n. So I am starting with the solution. You have log 3 base 2 into log 4 base 3 into log 5 base 4 into log n plus 1 base n is equal to 10. So what we are going to do, we are going to use the property of change of base. Change of base, what you have to do is, you can write this as log 3 by log 2. Same manner, this can be written as log 4 by log 2, or log 3. Same manner, this can be written by log 5 by log 4. Okay, so continuing in that way, the last term will be log n plus 1 upon log n. And if you are writing the term before this one, then the term you have is log n base n minus 1, correct? So it is going to be a like this, log n divided by log of n minus 1. So if you are going to check, then this 2 cancel out, this 2 cancel out, this will be cancel out with next one, this will be cancel out next one, this will be cancelled out with the first one, and is equal to 10. And that will give you log n plus 1 upon log 2 is equal to 10. And now log of n plus 1 is equal to 10 log 2, and that will be a log of 2 raised to 10. So log is going to be cancelled out from both sides, 2 raised to 10. Now 2 raised to 10 is what? 1024, correct? Okay, so this will give you n is equal to 1023, and this is the answer. Done? So these are the topics which we have covered in today's session. If you have any doubt or any query regarding these topics, then please feel free to contact me. Thank you so much.